How's everybody doing out there? Well, welcome to day 21 of Corona Online School. So, hopefully, everybody did a good job with the addition and subtraction of fractions. So, now we want to move on to multiplication and division of fractions. And so, let's dive right in so we can see what's going on. So, the first couple, you can see what we're doing is using a model to do these. And so, what we're doing is we're taking 1/5 of 10. So if you notice, we've got 10 dots to represent our number 10. And then what I've already done for you is kind of, since I'm doing 1/5, I've kind of divided this up into 1/5 chunks already. So if you didn't already, if this wasn't already done, that would be the first thing you'd want to do. And then 1/5 of 10 would just be to circle one of those fifths. So in this case, 1/5 of 10 would just be 2 in that case. So same thing, 1/3 of 12. So again, notice we've got 12 dots in there. Since we want to break this up into thirds, we broke it up into, four dots each. And again, since we want 1/3 of 12, we're going to circle just 1/3 of those. And so that would give us a 4 in this case. So go ahead, practice these on your own. So this is multiplying a unit fraction by a whole number. So remember, our unit fraction is the one with the 1. So I've got you practicing some unit fraction by a whole number. So pause the video at this point, do practice 1 and 2, and then when you're done, then we'll look at multiplying just a regular old fraction by a whole number. All right, so hopefully everybody did a good job with the unit fractions. So now multiplying just a regular fraction is kind of the same idea. So in this case, instead of multiplying by 1/5 times 10, we're going to multiply 4/5 times 10. So again, we've got our 10 circles to represent the number 10. Since we're interested in breaking this up into 1/5 chunks, we went ahead and divided this up into the 1/5. But now, in this case, since we want 4/5 of 10, then that means I want to circle 4 out of the 5 chunks in this case. So I want to circle this many and count how many I've got. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 that are circled. So 4/5 of 10 would give me 8 in this case. All right, similarly for 2/3 of 12. So again, we've got our 12 red circles to represent 12. Since we're interested in breaking this into thirds, we went ahead and divided these up into thirds. And since we want 2/3 of them, so again, now I'm going to circle 2 of these chunks. And then again, just add them up. So 1, 2, 3, 4, 5, 6, 7, 8. So again, 2/3 of 12 turns out to be 8 also. So 8's the magic number for this problem. All right, so I've got practice 3, 4, and 5 for you guys that are doing exactly the same kind of stuff. So give that a shot. Let me know if you have any questions or anything like that. And then when you're done, then we'll come back and look at example 3, which is multiplying a fraction by a fraction. All right, everybody do good with the multiplying a fraction by a whole number? So again, if you have any questions or anything like that, just let me know. I'll be around all day. So for this one, we're trying to multiply 1/2 times 4/5. So the first hint is to do, let's shade 4/5 of a rectangle. So the first thing we want to do is kind of divide this up into 5 chunks. So we need 4 lines to do that. So we're going to get 1, 2, 3, 4. And so again, hopefully they're pretty even if you do everything pretty well. And so we want to shade 4/5 of that. So let me shade it pink, say. All right, so there's 4/5. And so now the goal is I want to multiply this by 1/2, or I want to take 1/2 of 4/5. So in this case, so what's 1/2 of 4/5? So in this case, I would get, well, I like to do this. I like to kind of divide it up so I can figure out what the increments are. So in this case, I want to divide this even further, like that. And so I'm going to take half of this away. Oh, now I've lost track. Where's my big, there we go. I guess I didn't have to do that. So I've taken half of the colored part away. So in this case, when I divide them in half, then that gave me, it turned it into tenths. So I've got 1, 2, 3, 4 tenths, which I can reduce down to 2/5. So I guess I just could have left it alone and just divide. I didn't have to shrink it down further, but oh well, I wanted to. So it doesn't hurt to sometimes, but all right. So that is multiplying a fraction by a fraction. So I've got you guys doing the same thing in practice 6 and practice 7. So go ahead and practice those, guys, and then when you're done, come on back and we're going to talk about how to multiply mixed numbers, because this can be a little tricky sometimes. So, all right. So let's look at how to multiply mixed numbers. So I've written you down some steps here just to kind of help guide you in terms of what to do. So typically, I'm not even really a big fan, honestly, of adding mixed numbers. You know, I can do it and stuff like that, but I actually prefer to use improper fractions even for adding. Multiplication is pretty much impossible to do without changing this thing into a mixed number. So that's what we want to do first. So before we do anything, what we want to do is rewrite 3 2/3 as an uneven fraction, and then 5 4/5 as an uneven fraction. So remember, the way we change these around is we multiply the denominator by the big number and then add whatever that multiplication is to the top number. So in this case, 3 times 3 is 9, plus 2 is 11. So in this case, 3 2/3 is the same thing as 11/3. And now let's do the same thing for 5 4/5. So multiply 5 times 5 is 25, plus 4 would give us 29, all over 5. And so at this point, if it was possible, what you could do is you could start trying to cancel stuff out. Now you won't have, the reason it says reduce diagonally, so these fractions would have been in lowest terms to begin with, so there's no way like the 11 and the 3 would reduce because this fraction would have already been in reduced terms. Same thing with the 29 over the 5, because 5 4/5 was already reduced. So if we were going to reduce things, like we might be able to cancel something from the 11 and the 5, or we might be able to cancel something from the 29 and the 3, but we're never going to be able to cancel within the same fraction. And now, if you don't do that, it doesn't matter. Like you'll get the same answer either way if if you don't reduce early. If you just go ahead and multiply straight across the top, straight across the bottom, you'll get the right answer either way. But it sometimes does make the multiplication a little bit easier if you do it in advance. So here, notice there's nothing we can simplify anyway, and it just said if possible, so we can't really do the next one. So now our next step is to multiply straight across the top, straight across the bottom. So in this case, 3 times 5 is 15, and then 11 times 29. Oops, there's 1. Is going to be 319. So that's our answer for this guy. Now, typically, if your answer came as a mixed number, they usually want you to put it back as a mixed number in this case. So, usually if it comes as an uneven fraction, you usually leave it as an improper fraction. If it's a mixed number, you usually return it back to a mixed number. So in this case, let's go ahead and switch this back into a mixed number. So we need to take 15 and divide it into 319. So in this case, 15 times 2 gives us 30. Bring down the 1, bring down the 9. 15 goes into 19 one time with a 4 remainder. So it looks like in this case, our final answer will be 21 and 4/15 in this case. So again, just be careful, make sure you do a good job switching it from a mixed number into an improper fraction. simplify if you want. If you, in the beginning, try to make it a little bit easier. If you don't like simplifying first, just multiply straight across the top, straight across the bottom. Then you may have to simplify later, which is fine. That totally works. And then once you're finished with your, improper fraction, turn it back into a mixed number to finish it off. All right, so I've got a couple for you guys to practice here. So if you look at practice 8, that's what you're doing in that case. And then there's some kind of real world story problems for you guys to look at that are related to multiplication. So work on those. So up to 12, 13, 14. And then when you're done, unpause the video, come back, and then we'll talk about dividing fractions in this case. All right, is everybody okay? Everybody did a good job with all the different multiplications, mixed numbers, improper. All right, so if you have any questions or anything, definitely let me know. So let's move on to division here. So in this case, our problem states 4 campers need to share 5 liters of water equally. How many liters of water does each camper get in this case? So first thing, how many liters are there? So we've got 5 liters of water total. And so let's represent each liter of water with a rectangle. So in this case, I'm going to draw, so there's 1 liter of water. There's a second liter, third liter, fourth liter, and a fifth liter of water. And so how many campers are there? So there's 4 campers total. And so what they want us to do is write this as a division problem. So in this case, this would look like just 5 divided by 4, because we're trying to take 5 things and divide it evenly between 4 people. So that's why the 5 goes first. And so now we want to divide the liters evenly by 4. How many liters does each camper get? So in this case, the way I like to do this is, since I'm trying to divide each of these up by 4 people, I'm going to take each of these liters and actually kind of divide them up into 4 chunks in this case. Well, that wasn't very good, but because they're all uneven, but I'll leave it like that for now. So there's another 4. There's another 4. There's another 4. And there's another 4. And so what I'm going to do is I'm going to use a different color for each person. So I'm going to have like camper 1 is going to be this pink. Camper 2 is going to be the orange. Camper 3 is going to be this light blue. And then camper 4 will let be this brown. And so I'm just going to go through and actually figure out what part each person's going to get. So this is camper 1 gets this part of a water, 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 and this part of a water. Now I like to do it this way, just so that way I'm kind of guaranteeing everybody gets an even amount instead of me just kind of shading in a bunch of pink as I go along. Like I just kind of go through and be like, okay, well, each one gets a little bit out of each container. So let's go to orange and fill in what color person 2 gets. So here's the chunk of water that person 2 gets. Then we've got this little blue. So this is person 3's amount. And then finally, person 4 gets this last amount. And even though some of their rectangles look bigger, that's just because I can't draw. So everybody has the exact same amount. All right. And so if we look, at this point, we can see what everybody's got, but we only really have to count one particular person's amount of water, because everybody actually has the same because of the way we divided it up. So I'm just going to count the blue. So in this case, we've got 1, 2, 3, 4, 5. So we've got 5 parts of water. And how much is each part? Well, remember we divided this into a bunch of 1/4 chunks. So in this case, each camper is going to get 5 1/4 chunks, or 5 5/4 of a chunk. Or if we think of this as a mixed number, each person would get 1. So in this case, because these first four are going to make a 1, and then a 1/4 left over. So in this case, 1 and 1/4 would be our answer for that. All right. Is that okay for example 5? All right. So here you guys try practice 15, 16, and then when you're done that, unpause the video, come back, and we'll look at example 6 here, kind of involving a number line. All right, so hopefully everybody did a good job working with those fractions with models, dividing fractions with models. So with example 6, we want to divide a unit fraction by a non-zero whole number. So in this case, 1/3 is our unit fraction divided by 2. And so what we want to do is first kind of put 1/3 on a properly placed or properly marked and labeled number line. So in this case, I'm going to do, it's because I've got lots of room, I'm just going to make this go the whole way from 0 to 1. And then what I want to do is I want to divide from 0 to 1 up into 2 chunks, so that way I can get my 1/3 units. So in this case, I'm going to divide that into thirds. So in this case, there's my 1/3 on my properly marked number line. So let me highlight it just so we can see what we're looking at here. And so now our goal is, what we want to do is we want to divide that 1/3 chunk into 2 equal pieces. So in this case, what we want to do is we want to divide this in half. And so if you wanted, you could just go through and kind of divide the whole number line just to make sure we're on the right track. So if I divide this in half, then that's going to be 1/6. This would be 2/6, 3/6, 4/6, 5/6, and then 6/6. So what I've done is I've taken this number line, which I originally divided up into 1/3 chunks, and then divided it up into 1/6 chunks. And then the goal is, how much do I have? So in this case, I think I used purple before. Let me use this dark blue. So now, since I only took half of it, I'm looking at just that much of a chunk, which is 1/6 in this case. So how much is one piece is just going to be a 1/6 piece. So again, that's what we're trying to think of. It's like, well, how many ways can I divide this, and how many chunks can I actually get into there? All right. Is that okay with example 6? All right, so let's do the same kind of idea, doing a unit fraction by a non-zero whole number, but this time using a rectangle as our model. So in this case, first thing we want to do is show 1/2 using a rectangle. So in this case, that means we just need to divide this guy in 2. And then again, I'm going to shade it, say pink. All right, so there's 1/2. And now the goal is I want to divide one of the halves into 4 equal pieces, because I'm trying to divide this 1/2 chunk into 4 equal pieces, and then figure out how much one of those pieces is. What what fraction is one of those pieces. So in this case, you can divide this a couple different ways. So I mean, I could just draw a couple lines down this way and divide it up into 4. So I could kind of go like this. So there's a bunch of different ways you can kind of divide this into 4 pieces. So it's up to you, whichever way you prefer. Oh, I got to highlight this back in again. So in this case, it says you only have to divide it the 1. I tend to like to do the whole rectangle if it's just me, but so in this case, I want to divide this into 4 chunks, and technically I would divide that into 4 chunks too. And so hopefully I would notice that this is going to be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. So it's still my whole, but instead of having it divided into half, I divided it again. And by dividing it again, I turned it into a bunch of 1/8 chunks. And then again, we only care about one of them. So what's the size of one of these chunks? So in this case, it's just 1/8 or 1/8. All right, is that okay with everybody? All right, very good. So you guys go ahead, work on practice 17 real quick. So again, this is having you do both kinds. So using a number line model and an area model to solve them. So again, it's still just a unit fraction by a non-zero whole number. So practice that. And then when you come back, we're going to look at example 8, which is kind of the reverse. We're going to take a whole number and divide it in by a unit fraction in this case. All right. So let's take a look at this guy. So we're just taking 3 divided by 1/3. So what we want to do is we want to first mark 3 on a properly marked and labeled number line. So in this case, I need as much space as possible. So there's my number 3, goes way out to here. So again, let me kind of highlight it just so we can see it's this full distance. And so now what we want to do is we want to divide each whole into thirds. And then what we're asking in this case is, even though it's a division problem, we're trying to say how many 1/3 chunks does it take to fill up between 0 and 3. So that's really the answer we want to ask ourselves when we're doing this. So even though it's a division problem, how many 1/3 chunks is it going to take to fill from 0 to 3? So again, what we want to do is we want to divide this guy up into thirds, just like that. And so now let me take a different color, like a darker color maybe. Or, well, let's try this gray. And so what I want to see is how many like cubes, 1/3 cubes I can actually put in there. So in this case, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. These are terrible sized. Oh my goodness, they're horrible. So anyway, so as you can see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 1/3 chunks that I can actually fit inside of that guy. So in this case, how many 1/3 pieces are there in the 3 holes? So in that case, we've got 9 total going on there. All right, yeah, that wasn't very pretty at all. So I wonder if it would have looked better. Oh, let me try that. Let me see. Like this might actually look better. So if we go to our fraction strips, like this could actually look a little bit prettier. So let's turn this on. So this could have been a way that you could have done it with fraction strips. So there's our number 3. And then the goal is we're trying to see how many 1/3 chunks that we can fit alongside of these number 3s. And this is essentially what we're going to do with the area model. And so in this case, if I pick up my pencil here, so I can go through and I can count. You know, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9 1/3 chunks fit in that range between 0 and 3 in that case. So again, this is kind of this fraction strips are kind of fun. Like these come in handy for a lot of this stuff too. We could have been doing the same thing for multiplication and stuff as well. I should have pulled it up earlier. So let's go back, take a look at what the next one is. So again, this is complete the division problem, 2 divided by 1/3. So again, we could do the exact same thing by doing like what we just did on the last one. So if we went back to the Matthews thing, so I could actually just kind of get rid of some of this stuff. So like, let me get rid of these and get rid of those. So if you look, this is 2 divided by 1/3 right here. And so as we can see, we've got 6 total. So let's take a look at it using the area model just to see, make sure we get the exact same thing. So the two rectangles represent two wholes. So again, since we're dividing it by 1/3, we'd want to divide this up into 1/3 chunks. So we need two lines to do that. And then again, what we're trying to do is figure out how many 1/3 pieces actually fit in here. So we know each of these by design are 1/3. So we're not really worried about the fraction part. That just told us how to divide it up. Our answer actually comes from this whole number part by just counting how many of those 1/3 blocks do we actually have. And I can see that I've got 6 total in this case. So it takes 6 1/3 blocks to fill up a number between 0 and 2 in this case. All right, so you guys try practice 18 there, and then I've got some real world practice problems for you guys to work on. So practice 19, practice 20, 21, and then when you're done, unpause the video, come back, and then we'll look at dividing a fraction by a fraction. And then I think we're getting close to done here at some point. Yeah, getting close. We're not quite there. This is a long section, so be patient. You may have to take a break a little bit. So, all right. So let's look at dividing a fraction by a fraction. So complete the following division problem. So put 1/2 on a properly marked and labeled number line. So again, just to kind of motivate it, we're doing 1/2 divided by 1/6. So again, let me clear this out. So last time, even though we used 1, we could do the same exact thing here. We could bring this 1/2 strip out, and then we could look, and like we could cycle through some of these different, whoops, there it is, just to see kind of what's going on. So like there's thirds, there's fourths, there's fifths, so there's 6. So that's what we're actually trying to do. We're trying to take 1/2 and divide it by, I think it was 1/6. So we're trying to see how many 1/6 chunks would actually fit inside of 1/2. And so we can see the way we've got this written, it looks like it would take 3 in this case. And we could drag them up so we could actually show, whoops, let me turn that off. And we could actually drag them up so we could see, whoops, well, it helps to actually put them where you want them. And we can actually see there's 3 1/6 chunks in there. Let me erase this because now you can't see anything. There we go. All right, so that's kind of the motivation for what we want to do for this division. So again, we're just seeing how many 1/6 chunks will fit inside of 1/2. So let's go back and look at our problem here. So put 1/2 on a properly marked and labeled number line. So again, I'm just going to give myself some room here since I've got it. So I'm just going to put 1/2 in the middle. And then now I want to divide this number line between 0 and 1 into 1/6 in this case. So keep in mind, 1/2 is equivalent to 3/6. So that means I need to have a 1/6 and a 2/6 on the left, and then a 4/6 and a 5/6 on the right. So I need to do, kind of divide it up this way. So I'll get 1/6, 2/6, or 3/6, 4/6, 5/6, and then finally 6/6. And so again, how many 1/6 pieces are there in 1/2? So if I was thinking of these kind of like my fraction blocks, so I'd have 1, 2, 3. So I've got 3 1/6 chunks that fit in there. So how many 1/6 pieces are there in 1/2? So it turns out just 3 in this case. All right, so let's do the same thing for 11 here. So for 11, we want to complete the division 2/3 divided by 1/6. So again, just to kind of, because we've got the mathies, we might as well use it a little bit here. So let me clear this out, turn some of this stuff on. And so we had what, 2 2/3? I forget now, it helps to know. 2/3 divided by 1/6. So in this case, I get my 2/3. So I'm going to bring 2 of these guys out. And so again, before I even start moving stuff, I could go ahead and use kind of this line box up here, which allows me to change the units. So right now it's written in thirds, and so if I go backwards, it would go to halves. So in this case, I wanted it in terms of sixths. So I can look and see I've got a 1, 2, 3, 4. So it looks like I should have 4 6. So I should be able to grab these guys and put them right in there. And put 4 1/6 chunks in that spot. And that should give me exactly what I'm looking for in this case. So let's verify that it actually matches when we draw it. So again, divide this rectangle into thirds and then shade 2/3 of it. So let's divide it that way. And I'm going to use the pink. So there's 2/3 of our rectangle. And so now we want to divide this rectangle even further. We want to divide it into 6 in this case. So in this case, kind of the easiest way to divide this into 6 is actually just to go that way with it. And then the question is, how many 1/6 piece are there that are shaded? So in this case, I've got 1, 2, 3, 4. So just like I saw in the Mathies app, I ended up with 4 1/3 chunks or 1/6 chunks to fill up that 2/3 of a fraction box in that case. All right. So practice 20. Look at all these practice problems. You guys are going to be worn out by the end of the class today. So thank goodness the weekend's coming. So practice 22, 23. You guys work on those on your own. And then when you come back, unpause the video. We'll talk about how to divide mixed numbers in this case. So it's not much different than multiplying, just one kind of extra step. So when you're finished, unpause the video, come back, and then we'll go through how to divide mixed numbers. All right, everybody doing okay with division and stuff like that? So it's kind of fun. I like all the drawing and coloring and stuff like that. It makes it kind of fun and exciting for me. So dividing mixed numbers, so we want to start off exactly the same way we did with multiplying. So we first have to change them from mixed numbers to improper fractions. So let's do that off to the side first. So again, we want to take 3 multiplied by 3 to get 9, plus 2 gives us 11. And then we've got 5 and 4/5. So again, multiply 5 times 5 gives us 25, plus 4 gives us 29. So now we can go back and rewrite our division problem. So here's the only new step, the only different step. So whenever we're multiplying or dividing fractions, we're not really big fans of dividing fractions. So what we end up having to do is turn it into a multiplication problem. And the way we do that is we have to take the reciprocal or just flip the last fraction in this case. So what we're going to do is we're going to leave the 11/3 alone, change this into a multiplication, and then rewrite this as 5 over 29. So now at this point, now that we've flipped, if you notice, now we could actually reduce. So notice you don't try to reduce before you change it into a multiplication problem. You can't do that. So you have to wait until after you've flipped it. Then if things cancel, then you can cancel them. And again, they're only going to cancel diagonal because the 5 and the 29 were already in reduced terms. The 11 and the 3 would have already been in reduced terms. So we'd only be able to cancel things like the 5 and the 3 or the 11 and the 29. Now in this case, I can't cancel any of those. So the only thing I can do now is just multiply straight across the top, straight across the bottom. So in this case, 11 times 5 is 55. 29 times 3 is, let's see, 87 in this case. And so with this one, notice, change it to a mixed number if possible. So in this case, it's not actually a mixed number anymore. So it's actually just a regular old number. So 55 over 87 is the best we can do with this. Nothing simplifies. There's nothing to change or anything like that. So we're actually done with this example. All right. Everybody okay with dividing mixed numbers? All right, so I've got a couple on here for you to practice. So practice 24, practice 25, 26, 27, 28, 29. Look at that. So everybody should be jumping in, doing multiple problems, so that way we can check each other's work and stuff like that. There's plenty of practice problems to go around, so don't be shy. Post some stuff up to the collaboration so we can all share our answers and stuff like that. If anybody has any questions, I'll be around all day tomorrow. So good luck, and I'll talk to you tomorrow.